The differentiation question in C2 is often one of the most difficult questions. This one's worth 12 marks, so let's take our time through it. We've got a right circular cylinder. That just means a cylinder basically, which isn't at a weird angle, so just a normal sort of cylinder like a Coke can. Radius is r and the height is h. Now that tells us that if we were to draw a net of this would be a rectangle wrapping around the two circles, one for the top and one at the bottom. Height h. Right, we're now told the surface area is 800, so the surface area 800 equals 2 pi r squared, that's two circles, add the rectangle, which is 2 pi r, that's the circumference of the circle, which is this length here, times h, so 2 pi r h. Okay, now divide that whole thing by 2. We'll make h the subject because they're asking us to basically write the volume with no h's involved, so I'm going to make h the subject. Divide everything by 2 and then take that over there, so we get h equals 400 over pi r. This might take a couple of lines if I didn't have to write this mouse. 400 over pi r minus 2r. So that's h. Now volume equals pi r squared times h. So we need to multiply this by pi r squared. So volume equals this times pi r squared gives us 400r. Looking good. And the other one, minus 2r times pi r squared is, it shouldn't be minus 2 at all, sorry, that's wrong. The 2 cancelled. So pi r squared times r is pi r cubed, and that's as required there. That's only worth 4 marks. Use the calculus to find the maximum value of v to the nearest centimetre cubed. Maximum value of v, given that r varies, is when dv by dr equals 0. Maximum points are always when the rate of change is 0. So dv by dr equals 400r differentiates to make 400. Now remember, pi is just a number, so this gives us minus 3 pi r squared. I knew this was going to happen, now I'm going to need a calculator. Okay, and that equals 0 at the maximum point. In other words, r squared equals 400 divided by 3 pi. So r is a square root of 400 over 3 pi, which is, I don't know, a bit more than 6, I suppose. Now I'm not going to actually do that because you can do that on a calculator, but it's a bit more than 6 is what r is. Then we need to put r into here to find the volume. They're asking us to find the maximum value of v. So work out what this is, chuck it into what the volume is, which is in this equation here. Justify that the value of v found is a maximum. Well, for this we need the second derivative. So d2v by dr squared, the second derivative, and we're hoping that the second derivative is negative. Well, the second derivative equals nothing minus 6 pi r. So it's minus 6 pi r. And for the value of r we just found, that must be negative, and so is a maximum point. And that's our 12 marks there. Now on to May 2006. We're not going to do all of this question because some of it involves integration, so it's a bit of a combination of calculus questions. We're only going to go up to down to there, so 6 marks. Use calculus to find the x coordinates of a and b. That's the maximum point and the minimum point of this curve. So we need to differentiate. Y primed equals 3x squared minus 16x add 20. Okay, and we find out what that is. When that is 0, we get this equals 0, so oh crikey, I don't know if this is going to be able to be factorised. I'll give it a go, hoping that we can factorise. There's 3x squared, we want 20, so 5 and 4, that's no good. 10 and 2, 10 and 2 is good. So minus 10 here, and minus 2 there, that should be right, minus 10, minus 16, so that's right. So x equals 2 or x equals 10 thirds, so that's hoping that that's 10 thirds, and that's 2. Now we need to find the whole coordinates, so we need to now put the value 2 into this to get the y coordinate. 2 cubed is 8, take away 8 fours, so take away 32, add 40, so that's 8, add another 8, I think 16, 2 comma 16 here, I think. And I can't do 10/3 in my head, but chuck 10/3 into that to find the y coordinate here. Next part of the question says find the value of d2y by dx squared at a, and hence verify that a is a maximum. Second derivative equals 6x minus 16, and when at point A, x is 2, so this is minus 4 at A, and that means that A is a maximum because its second derivative is negative.